another circle. Just what beautiful shapes, aren't they? Just look at them. And then just go so circular. Okay, anyway. So again, point is, let's just have a look at what we've got so that we can look into solving a question like this. You're given a whole lot of information. As always with these, check that everything you've been told is in the diagram. It's not always, because it might tell you that this doesn't look like it does tell you this, but if CB equals BA, you imagine it would be quite hard to show in the diagram. You'd put two lines and then two, it would be quite hard to show, so you might be told information up here that's not in the diagram. So run through it and just check. Things that look like straight lines are straight lines. AOD is a straight line. Cool. What does that make AOD? Makes it a diameter. So this thing here, you go, oh, okay, immediately we've got a diameter over there. Could be useful. AD is perpendicular to CB. So this bit here is that 90 degrees they've shown us. OA equals 5 units, I think, from what I've half crossed out there. So that's 5. Okay, so this distance over here is 5. DS equals 2 units. Let's see, what else can we cross out in the process? This thing here equals 2 units. Well, there's a 2 there, so let's just do that. And the area of CSD equals 4 units squared. CSD is 4 square units. So this thing here, that area equals 4 units squared. Okay, how do you think the area is going to help us at some stage? Well, you could work out backwards. You know how to work out the area of a triangle, right? Do you? Okay. Half base times height. Well, we know that that distance here is 2. So therefore, this other distance here, well, this bit must be 4, right? So that's going to be 4, because you could sub it in and go, well, 4 equals a half. Let's make the base 2 times height. And therefore, 4 times 2 is 8. 8 times a half is 4. Or however you'd work that. Half times 2 is 1. 1 times h is 4. That was a lot easier, wasn't it? Okay, so h equals 4. So that might be useful. If you've got the line that we've got a line from the center and it's perpendicular to a chord, you know it's that one theorem. In grade 10 we started with it, and it always rears its head in this type of question. Sometimes, where was it? One of the previous exams. Was it a grade 10 or 11 one a few years ago? And there was a nice way to solve a much trickier problem if you remembered this theorem. Anyway, so if that's 4, we know that that's going to be 4, but why? I don't even know what we have to figure out yet, but what's our reason for saying that this is 4? Looks like those two are the same. Well, that one was perp from center to chord. So I think we used the reason perp from center to chord. Remember, it's not line from center to midpoint of chord. We're not told that it's the midpoint. We're told that it's perpendicular, so that's why you're going to use this reason. Okay, so you've got 4, you've got 5, you've got this distance. You can probably work out AB because there's a right angle triangle. Who are we going to use for our right angle triangle, do you think? I'd be quite keen on using Pythagoras. I was reading something interesting this last week, that the theorem of Pythagoras was used about 1,000 years before Pythagoras was around. And even Pythagoras probably didn't come up with it. It was a group called the Pythagoreans that were using it. But as I say, I think the Babylonians were using it 1,000 years before them. We've documented evidence of this. So hey, in 1,000 years' time, you can look for a theorem that was made 1,000 years ago. Maybe it'll get named after you now. Anyway, we've got that. Maybe the last piece of the puzzle is just always be on the lookout for these beauties called radii, because that distance is going to be the same as that distance because it's a radius, so that whole distance is 5. So you can work out that distance. Cool. What do we have to work out? AB. Nice question. Doesn't ask you to figure out each little bit, but notice how we could figure out each bit. And at this stage, if you're practicing early enough, You can practice just to look and get into the questions and have fun with them. And really, I mean that. Have fun with them of, okay, what can we do here? Oh, we could work that out. Oh, we could find out AB. Okay, yeah, we're going to use an efficient way to get there quickly and not solve everything that we don't have to. But because you have spent the time and invested it, when it comes to AB, I can solve anything. Give it to me, I'll solve it. You asked me to find the area. The question could have said, maybe one of the versions was, determine the area of triangle SAB. SAB, determine this area. And then you have to know, oh, well, I'd need to know that side, I'd need to know that side. And then you wouldn't have to work out AB. So it would have been another way. And because you've got into these questions and spending this time, it's worth it, as opposed to just, oh, the length of AB, so what do I do? Okay. So yeah, invest the time. It's worth it.